Hi all. Today we will discuss what is neuron in neural network. A neuron, also called as a node or unit, is the basic building block of artificial neural network. It is inspired by the biological neuron found in the human brain, which receives signals, processes them, and sends an output. So, coming to a simple model of artificial neural network, it does consist of an input layer as well as an output layer. It is a minimum structure required for a ANN to be met. Coming to the key components, we can go with connections. Connections are the links between neurons that carries information regulated by weights and bias. So the connections or the links, you can assume it to be some wires that carries information or messages from one neuron to another. Then coming to the weights and biases, these are the parameters that determine the strength and influence of connections. So if the weight is high, that means the information is important. And if the weight is low, that means it is less important. Then moving forward to bias. Bias is an extra value. You can say augmented value as we discussed earlier. You can imagine bias as a small push that helps the neuron make better decisions. Okay. So bias is just like adjusting the starting point of the neuron to improve accuracy in the output. So coming to the propagation function or so-called the activation function, The propagation function, also called the activation function, is a mechanism that helps process and transfer data across layers of neuron. It is like the decision is made like should the neuron activate, should it send a strong signal, should it send a weak signal, or should the output be zero. These kinds of decisions are being made through the activation function. Then a neuron does have a summation function as well. We will discuss this up in the next slide. So next one is the learning rule. This is the method that adjusts weights and bias over time to improve accuracy. So if we are not getting the desired output, we will be backtracking, or we can say we will be changing or modifying the values of the weight values here. Okay, this is how a simple ANN model works. So we can take a simple example. There are three inputs x1, x2 and x3. Where W1, W2, W3 are the weights assigned to its connections or links. So here in this, there is an input layer and an output layer. Here there are four neuron, that is x1, x2, x3 and one neuron for getting the output, or you can say. So in each neuron there is two functions being assigned, that is the summation and the activation function that we discussed earlier, the propagation function. So the activation function is actually applied to the neuron at the end after the summation is being done. So the neuron computes a weighted sum of all inputs plus bias term. We can denote it using Z or Y in. We would be taking the summation along with the bias term. So here we are taking only W1 x1 plus W2 x2 plus W3 x3, as there are three neurons at the input layer. This step is called the linear combination or summation function. It linearly combines the inputs and prepares them for the next step. That is, once we get the sum C, the neuron does not directly sense it out. First, it passes C through something called an activation function, right? The propagation function, as we discussed earlier. The equation for that is y is equal to C, f of C. That is, sometimes we could, the function entirely depends upon what is the desired output. That is, we could be using some sigmoids or some step up function or some directly implementing step up functions as well. So it entirely depends upon what's the output is desired. So after the activation function processes the value, we get the final output y. This output is sent to the next neuron. So if the output that we are getting is not the desired output, or the accuracy of the function is not that relevant, or if that's not clear, or if the accuracy is not that desired, we will be changing or modifying the values of the weights assigned to the connections, and we will change or modify the weights till we will be getting the output. This is how the learning rule works in the ANN as well. This correction helps the neuron learn better. Okay, this is how the neuron learns better. Neurons learns better. So the learning rule is like a teacher correcting a student's mistakes so that the students improves in the next attempt. This is how a simple architecture of ANN works, or you can say this is how a simple ANN works. That's it. Thank you.